Hi guys and girls. The last thing we're going to learn this unit on sequences and series is something called the Binomial Theorem. This is also called the Binomial Expansion. And this is a very neat way of expanding out binomials. And by binomials, I mean we've got like a plus b to some power. Let's do a few of them. A plus b to the 0 power is 1. That's pretty easy to do. A plus b to the first power is just a plus b. A plus b to the second power, some of you thought earlier on in your math career, like as soon as like a few months ago, you thought this was a squared plus b squared. But you know that you have to multiply this out by foiling, or you have to double distribute, or whatever you do with your box, and that's what that works out to be. And then we also learned a formula for a plus b cubed. And this was a cubed plus 3a squared b plus 3ab squared, and then plus b cubed. Now at this point though, once we get to a plus b to the fourth, we're in trouble because we don't have a formula for that yet. But this would be a plus b times a plus b times a plus b, or you could think about this as a squared plus 2ab plus b squared times a squared plus 2ab plus b squared, because that would be a plus b squared times a plus b squared. Imagine multiplying all that out. No thank you. That times that times that, that times that. No. That's going to be a mess. But you could do it. The binomial theorem is typically used for something that's very inconveniently large on this exponent, like a plus b to the 7th. Now there's no way we're going to sit there and multiply that all out. So that's what we have to learn to do. So let's learn what this is. This is a series. Here's our little summation notation. A plus b to the n is our series. We understand the k equals 0 to n, but this little parentheses here we haven't seen before. This stands for n choose k, or NCR, used in probability a lot. Sorry, it's NCR on the calculator. We'll NC k here. And then we have a to the n minus k power and b to the k power. And this is an easy little pattern to see, so I'm going to show you that. First of all, I'm going to show you what this little parentheses things mean here. N choose k, or on the calculator it's going to be n choose r. N choose k means take the top number up here and put an exclamation point on it. That stands for a factorial. And no, I'm not yelling at you. I'm not going in. That means n times everything underneath it down to 1. So these little exclamation points you need to learn to deal with. So let's take a look at that. Here's an example of 10c7. We put the 10 on top of the factorial, and then we have 10 minus 7 times 7 factorial. 10 factorial means multiply all the numbers together from 1 to 10. 3 factorial is all the numbers from 1 to 3, and 7 factorial is all the numbers from 1 to 7. Now, instead of multiplying all these out, there's this convenient canceling thing we can do. You can cancel all the numbers from 1 to 7 on top and all the numbers from 1 to 7 on bottom, and then it's easier to simplify that way. And then, of course, 2 goes into 8 4 times. You can see I've worked this out down here. 3 goes into 9 3 times. And so what you have is 4 times 3 times 10. It works out to be 120. Now that's the math behind that, but luckily for us there's a button on our calculator that will do all of this stuff for us. So I want to show you where that button is. And if you go to your math and you go over to probability, your button is right there. It's NCR. And so what you do is you have to actually type in the number first. Then you go to math over the probability and get this NCR. You see why I have NCR here, or why I wrote NCR earlier, because that's what it is on the calculator when it was NCK. You go to the NCR and then you hit 7 and you hit enter, and it will do all of that math for you, and we're going to take advantage of that. These numbers come from something called Pascal's triangle, and you should investigate this if you ever want to look at something that is very interesting. It has a lot of patterns in it. I'll show you some later, but for the sake of keeping this video under 5 hours, we're not going to look at all those patterns. But Pascal's triangle starts with a 1 and it's got 2 1s. And the basic idea is any number can be found by adding the numbers directly above it. So this number 3 is because 1 plus 2 is 3. This number is 6 because 3 plus 3 is 4. So you can look at it. Each number is the 2 numbers directly above it added together. There's a lot of other patterns here. But I want to show you what 6C4 is. Now 6C4, the way you find it on Pascal's triangle, is you ignore the ones going down the column and you look for the first column that's got a 6 on it, and that's this column right here. So you go to that column, and from there you count this 6 as a 1. So you go 1, 2, 3, 4, and that is 6C4 right there, 15. Your calculator, of course, will do that for you, but I just wanted you to see. If you want to find this, all of those numbers are in Pascal's triangle. All right, so let's do an example. We want to expand x squared plus 3 to the 6th, and we want to use our little triangle. So all of our coefficients are going to look like this. 6, choose 0, and then we're going to have x squared to the 6th times 3 to the 0, and then plus. Then we're going to have 6, choose 1, and we're going to have x squared to the 5th times 3 to the 1st, and then plus. Now I'm going to have 6, choose 2, x squared to the 4th times 3 squared, plus 6, choose 3, x squared to the 3rd times 3 to the 3rd. I should have had this exponent on the outside here. I know it doesn't matter there, but it will matter later. Plus 6, choose 4, x squared squared times 3 to the 4th, plus 6, choose 5, x squared to the 1st times 3 to the 5th, and the last term is 6, choose 6 times x squared to the 0 power times 3 to the 6th. Now let's look at this neat little pattern. Your first term in your binomial, your a, you start with the power of 6, and then you just go ahead and start decreasing. So it's x squared to the 6th, then to the 5th, then to the 4th, then to the 3rd, then to the 2nd, then to the 1st, then to the 0 power. Then you go backwards with the second term, or your b. You start it at the 0 power, and then you build it up 1, 2, 3, 4, 5, until it gets to the 6th power. So let me show you on Pascal's triangle where these numbers are. The 6, choose 0, 6, choose 1, and 6, choose 2 all come from this row right here. And so those are the numbers that I'm going to put there. 1, 6, 15, 20, 15, 6, 1. So that's going to be 1x to the 12th, because we know we take a power to a power, we multiply. And then 3 to the 0 is 1. Now 6 choose 1 is 6. And by the way, anything choose 1 is itself. So I'm going to have 6x to the 10th times 3 to the 1st. And then 6 choose 2. Oh, I went to the answer. 6 choose 2 is 15. So I'm going to have plus 15 x to the 8th times 3 squared, which is 9. And then 6 choose 3 is 20. X to the 6th times 27. And then 6 choose 4 is 15. X to the 4th times 81. I'm going to have to go to another row here. Plus 6 choose 5 is 6. X squared times 3 to the 5th, which happens to be 243. And then plus 6 choose 6, which is 1. X squared to the 0 is 1. And 3 to the 6th is 729. So look at these numbers here. 1, 6, 15, 20, 15, 6, and 1. Those come from Pascal's triangle right here. And then we start with our a, and we take it to the 6th power, then the 5th power, then the 4th power, then the 3rd, then the 2nd, then the 1st. So that's why we have x squared to the 6th is 12, x squared to the 5th is 10, x squared to the 4th is 8, x squared to the cube is 6. You see the pattern. Then you start your b, and you go backwards. You b to the 0, b to the 1st, b to the 2nd, all the way up to b to the 6th power. And this should look like, once you clean this all up, this answer right here. So that is a way, it's called the binomial expansion, and you're going to practice this tomorrow. You're definitely going to want to make sure you pay attention very closely tomorrow, because there's going to be questions like, what's the 5th term in the expansion of this? And you're going to definitely need to be on your A game tomorrow, making sure you want to learn how to do these questions, or they're going to be a bear for you whenever you take our test. So I want to see you guys tomorrow in tip-top math shape. I'll see you then.